We are making our way inside the brain. We started with the cerebrum, and specifically with the cerebral cortex, which is the gray matter around the outside of the brain. And now we're moving deep to that. We're still in the cerebrum, but we are doing the white matter in the cerebrum. Okay. So before I go any further, I do want to reiterate that when we're in the halves of the cerebrum, the hemispheres, the lateral ventricles that we talked about before are in the halves of the cerebrum, right? One in each cerebral hemisphere. Okay, so now we're moving in and we're going to look at the white matter. Now, when you look at white matter, most of the time you see it this way. So this is the white matter that's within the cerebrum, and then some of this is white and some of it's gray. But there's lots of white matter that you're seeing, or it looks like this. But what it really is a whole bunch of different fibers. So this is a dorsal view of the brain, which is a really cool dissection. The cerebral cortex out here, remember, is where all this kind of processing goes on. And then what you need is wiring between the portions. So for instance, the right half of your brain will need to know what the left half is doing so that you can coordinate your left and right feet so that you could walk or do anything that requires coordinated activity, for instance. You're going to need those to communicate with one another. And the way that you do that is with white matter. White matter, remember, is primarily myelinated axons. If white matter is myelinated axons in the peripheral nervous system, it's called a nerve. But when it's in the central nervous system, they're called tracts with a T, T-R-A-C-T, or pathways. Now, there's a whole bunch of different kinds of tracts and pathways. Really, all I want you to know is the basics of it. So here is a really cool model that somebody made that I would just love to have. This is a model of all of the white matter tracts in the brain, which is just fantastic. And this is an art piece that is colorizing all the white matter in the brain, which is just really cool as well. So all I really would need you guys to know is 3 general types of tracts as far as the white matter in the brain. And they are, depending on which direction the white matter actually goes. So can you tell here that some of this white matter is going from the left side to the right side, right? Some of it's going up and down, right? And then although you can't see it in that picture, you can see it in this picture. There are some that are communicating within the same cerebral hemisphere. So let's just learn some general terms for each of those. White matter tracts, remember we're talking about wiring, that go front to back or back to front within a half of the cerebral cortex. These purple ones right here are called, I call them association tracks. They changed the name in your textbook, but we're still going to call them association tracks. So association tracks go front to back within the same side of the brain. And these little guys are like subtypes of association tracks. We won't learn those. The tracks that go left to right from one side of the brain to the other that you see right here, or again, right here, those tracks are called commissural tracks. They connect left to right side. So these guys in blue right here. And then the ones that go higher central nervous system to lower or lower to higher are these guys right here that are called projection tracks. And you can think about that like projecting upwards. And the reason you have this whole left side of the brain is about the right side of the body and right side of the brain is about the left side of the body is because at some point in evolution, well before humans, these tracks actually crossed, and they cross in the medulla oblongata, so that things that originate here on the left side will end up going out to the right, and the other one goes out to the other side. So it's because of the crossing of the projection tracks in the medulla oblongata that occurs. So again, what you are looking at here is when you look at white matter, it just looks like blobby white matter, but that's not what it is. It's a whole bunch of wiring that's going different directions. Okay, so that is what we call the central white matter, the white matter that is deep within the cerebral cortex. And then if you go even deeper into the cerebrum, this is a coronal section, of course, you're going to see gray matter, which was the cerebral cortex, and then we had the white matter, including this one, which would be a commissural tract, and then these guys, which would be projection tracts. You wouldn't have to know that from this picture. But then look, there's also some gray matter that is deep within here, okay? This gray matter that's deep within there includes this one, these guys, this one, that one right there. What those are is paired chunks of gray matter within the cerebrum that are called cerebral nuclei. Sometimes also called basal nuclei because they're kind of at the base of the brain. And commonly, but incorrectly, very often they are called basal ganglia. Don't use that term because ganglia is only correctly used for the peripheral nervous system. Even though that's really commonly used, it's actually incorrect. So they are paired internal structures of gray matter within the brain. They're kind of clustered, so here was the insula, right? Here's the third ventricle, the lateral ventricle. That's where those guys are. And what do? Well, they do a whole bunch of different things. So I'm just going to give you a couple of important things. I don't know if you've ever heard of the amygdala or the amygdaloid body. That one is involved in emotion, fear, and vigilance. It's kind of your on alert part of the brain. If you have been living a very stressful life, that thing gets lots and lots of blood flow and activity. In people who are anxious, it gets quite a bit more activity. And then these guys, 1, 2, 3, not this green one, that's actually part of something else. These guys right here. So they have to be kind of lateral. The ones that are in the middle are actually part of a different structure. I won't make you identify them individually. Just knowing that these are the cerebral nuclei is totally fine. So when you're moving out, these guys right here, one of the things that they do is when I decide I want to, for instance, start walking, I actually send that signal from my cerebral cortex through the cerebral nuclei before it makes it out. So it's kind of responsible for like initiating skeletal movement. When I think of it, I send it through the caudate nucleus before it goes out. One of the cerebral nuclei. You don't have to know which ones are do what. And these guys in here, one of the things that we know about them that's kind of interesting is that Parkinson's disease and Tourette syndrome originate because something is going awry with your cerebral nuclei. Okay, so that's a short one, and then we're going to do the diencephalon.